To find the area in between these functions rotated around the x-axis, we have to have our equation in terms of y. Our p is going to be y, while our h is going to be 7 minus y. First, we can distribute the y to 7 minus y, and once we integrate that, we end up with 7y squared over 2 minus y cubed over 3. Our interval runs from 0 to 7, so 0 is going to end up being 0, so we just have to focus on 7. Plugging in 7 into the equation, you get 343 over 3 minus 343 over 2. I messed up and accidentally wrote 2. Once you get a common denominator and subtract, you can multiply by 2 pi. Simplifying that will give you your final value of 343 pi over 3. This time we're using the disk method. First thing we're going to want to do is change it into terms of y. The little r of our disk method equation is going to end up being 0, so we don't have to worry about that. We're squaring our first equation. Once we do that, we get y to the 8 over 3. Then we can integrate that and multiply by pi. Plugging 1 into the equation and multiplying by pi gives us 3 pi over 11. This question states that 15 pounds stretches a string 11 inches and asks us to find the work in stretching it 2 feet. Using Hooke's law, we know that F is 15 pounds and that our x distance is 11 inches. Solving for k, we get 15 over 11. Knowing that our spring constant is 15 over 11 allows us to put this over the interval of 0 to 24 inches, which is 2 feet. After integrating, we will plug in 24 to the equation. Multiplying 15 over 11 times 288 over 12 due to putting the inches back into feet ends up giving you 360 over 11.